Hi guys, I'm going to go through these examples with you from your work, energy, and power guided notes. So here we go. All right, so the first thing we're going to do is we're calculating work. If you remember, the formula for work is work equals force times displacement. So it says a tugboat pulls a ship with a constant net horizontal force of 5 times 10 to the third newtons and causes the ship to move through a harbor. How much work is done on the ship if it moves a distance of 3 meters? So work, again, is equal to that force. So 5 times 10 to the third newtons times your displacement, which is 3 meters. And that's going to give us an answer of 15,000 joules. Okay, so the next one, I got to move this. How do I move this? Hold on. Okay, I figured it out, obviously. So if the number, reading is hard. The second one says, if 2 joules of work is done raising an apple with a force of 12 newtons, how far is it lifted? So for solving for displacement is going to be equal to work divided by force. So your work is 2 joules and your force is 12 newtons. So that's going to give you an answer of 0.16 repeating, but I just rounded it to 0.167 meters. All right, your next one. Says a person pushes a shopping cart a distance of 5 meters while doing 120 joules of work. What force is exerted in the shopping cart? So again, we can manipulate that formula again. So force is going to be equal to work over displacement. So if your work is 120 joules and you're dividing that by 5 meters, you're going to get an answer of 24 newtons. All right, so let's move on to the next set of examples. All right, so this is determining whether work is being done in each of the following scenarios. So remember, for work to be done, it's going to have to result in motion that's parallel to the force that's being applied. So the first one says a train engine is pulling a loaded boxcar initially at rest. So it's pulling something in the same direction it's going. So yes, work is being done. The second one says a tug of war is evenly matched. So they're each pulling in the opposite direction, but nothing's moving. So no. And this one says a crane is lifting a car. So you have a crane that's lifting up and it's lifting some sort of object up. So yes, on this one as well. These examples want to know if work is being done in a positive or negative value. So for positive or negative value, again, you have to know, is work being done? Yes or no? And I will tell you in all 3 of these examples, work is being done. And then if it's occurring in the same direction of the work, it's going to be a positive work being done. If it's occurring in the opposite direction, it's going to be negative work. So the first one says a road exerts a friction force on a speeding car, getting it to a stop. So you have your car that's moving and friction's actually moving in the opposite direction. So this is negative. The next one says a rope exerts a force on a bucket as the bucket is raised up. So the bucket's being raised up and the force is saying that it's also raising it up. So this is for it, so it's positive. And then this one says air exerts a force on a parachute as the parachute falls to the earth. So your parachute is falling down and air is going up. So this is negative as well. All right, so now we're going to use kinetic energy. So kinetic energy is 1/2 mass times your speed or velocity squared. The first one we're actually solving for speed, which is the variable v. So v is equal to your square root of 2 kinetic energy over mass. So your square root of 0.145 kilogram baseball, if its kinetic energy is 109. So 2 times 109 joules. Oh, my J looked funny. Divided by 0.145 kilograms. Reading is really hard today, guys. I'm sorry. And that will give you an answer of 38.77 meters per second. The second one, we are solving for mass. Mass is going to be equal to 2 KE, or 2 kinetic energy, divided by velocity squared. So it says a car has a kinetic energy of 4.32 times 10 to the 5th joules when traveling at a speed of 23 meters per second. And you're going to square that. So when you do this, on number 2, you're going to end up with 1,633.27 kilograms as your mass. Be really careful with your parentheses when you plug these in. And then number 3, we're solving for kinetic energy, and that formula is equal to 1/2 mass times velocity or speed squared. And I don't know why that M looks so funny, but it does. Okay. So 1/2, your mass is 1.45 kilograms, and your velocity was 1.25 meters per second. And make sure you square that. Again, 1/2 you can do a 0.5 in your calculator, and you'll get the answer of 1.13 joules. Now let's talk work kinetic energy theorem. So these are kind of weird, but your work kinetic energy theorem tells you that the work done on an object, or the net work done on an object, is equal to a change in kinetic energy. And since we know that work equals force times displacement, and we know that kinetic energy is equal to 1/2 mass times velocity squared, we can say that force times displacement is equal to 1/2 mass times velocity squared. In this first one, we're given a kinetic energy, so we can just say F times D equals 352 joules. And we're actually given a force as well. So we say 45 newtons times, that's an N, your displacement is equal to 352 joules. We're going to divide both sides by 45 newtons, so you get your displacement by itself. So your displacement is going to be equal to 7.82 meters. All right. And the last one, again, we're using the same formula. FD equals 1/2 mv squared. It says a 45 kilogram bobsled is pushed along a horizontal surface by 2 athletes. After it's pushed a distance of 45 meters, starting from rest, its speed is this. Find the magnitude of the net force. So we're solving for force this time. So we know that force times, we're given a distance of 4.5 meters, equals 1/2 your mass, which is 75 kilograms. And then your velocity was 6 meters per second squared. These problems are mostly just, finding out what your variables are and plugging them in. So know your units really well. So if we divide both sides by 4.5 meters, you get force by itself. This whole top section here is in fact equal to 1,350 joules, if that makes it easier for you. And when you divide that by 4.5 meters, you will get 300 newtons. All right, I'm going to stop here for now and come back and see me for the next part.